Have you ever been frustrated by the lack of battery life in your device? Here's a solution. This bad girl here is 3.24 kilowatt, 3.24 kilowatt hours of lithium battery pack. So there's a big monkey. I'm gonna have to. Do I say 22 kilos? Hold on. There it is. It's like bigger than my head. Yeah. Yeah, it's really heavy. Okay. Yeah, I mean that'll keep you vaping for a little while. I mean, probably not so good as far as convenience goes and portability. Yeah, but I mean, like, you're not going to run out. You can vape for probably a few months on this, I reckon. So this huge battery pack, big lithium battery pack, it's out of an e-bike, electric bike, and I don't mean like a little small bike you ride on footpaths. This is like a proper registered road-going vehicle that this goes in. It'll do about 100 kilometers an hour, I think, is the top speed of this guy. So yeah, basically full, kind of scooter, moped replacement kind of bike. Specs on this guy, 3.24 kilowatt hours, 72 volts at 45 amp hour. Yeah, there's a lot of power in this thing. Now, what's going on with this, why it's on the bench, won't charge this guy. For whatever reason, it's actually a new pack. For whatever reason, this has dropped below what voltage it needs to be at for the charger to charge it. So it's basically safeguarding the charger that if the pack voltage drops below a certain level, the charger says, no, not going to charge it. In this case, I think it's only just below. So it's either self-discharge or the battery management board inside has discharged the pack down to 58 volts. It's a nominal 72. So at 58, we're looking at about 2.9 volts per cell. So not too low. I think just below what the charger wants to see before it'll charge. Well, what that means is that this pack is not usable. So we've got a new bike with obviously a new battery in it, and we can't charge it. It won't run the bike, obviously, because it's flat, and we're stuffed. We've got a new one on the way to replace it. But what I'm going to try and do, today's mission, is to bypass the battery management board that's inside this guy, manually charge it up to the point where the charger will kick in and actually charge it. So it's a pretty sketchy operation. Now, trying to revive over-discharged lithium cells generally is not a good idea. What can happen is when a cell is sat below, normally about 2.5 volts, and the lower you go, the worse. And depending on how long and how low it's sat at that voltage, you'll get internal damage in the cell. What will happen is the copper anode inside the cell will start to dissolve into the electrolyte as it's sitting there fully discharged. And when you go to charge that cell, all those copper ions will actually start to plate inside the cell. And it's possible that they can grow little spiky bits. And basically when they're doing that, there's a chance that that copper can short through the layers of the cell and essentially short out the cell itself. Now, if that happens, it's very, very bad. You could be... It could just get warm and self-discharge quicker. It could be a full-on hardcore short. Battery could go into thermal runaway, venting, all sorts of stuff. So generally really bad news. Now, the 0 volt activation battery revival function on some external chargers, for that reason, it's not a good idea, generally. It's stupid. If a lithium battery's been sitting at 0 volts, like you grab one and it's been sitting in the cupboard for God knows how long, and you go to charge it and it's sitting at 0 volts or like not far off, it's done for. Just throw the thing away. Well, recycle it, get rid of it, don't charge it, because anything could happen. It could charge up and it could be usable for a bit, and then you could have a problem. You just don't know. It's absolutely not worth it. Now, in a pack this size, calculated that if they're 1500 milliamp hour per battery, per cell, individual cell in here, you're looking at 600 cells. Now, if only one of them has a problem even after being charged up, say, that's been way over discharged, one goes off in the middle of this pack and goes nuclear, the whole thing's going to go off. So we're looking at major issue, very bad stuff going on. At 2.9 volts, I think this is worth charging up or trying to do a tricky manual charge to get it back up. I don't think there's too much of an issue, especially because I know this had been up at a decent voltage not long ago. Okay, so what we're going to do. We're going to get this thing apart. We are going to bypass the battery management board, and we're going to manually charge it in series. Actually, once we get it open, we're going to check to make sure each different one of the 20 series cells or packs are at a decent voltage, that none is like below a certain level or none's like way less than the others for some weird reason. We're going to make sure they're all looking healthy, and then we're just going to charge it in series. Now, I don't have a power supply with a high enough voltage because I'm looking for around about 65 volts. It's currently at 58. I don't have a 65 volt power supply, but what I do have with me is I have 6 of these guys, which is just a 12 volt lead acid battery, motorbike battery. I'm going to series up 6 of these, give us 70 something volts, and use that as a power supply to charge the pack inside. Trick being though, these guys can put out a heap of current if you put them into a almost shorted load, which is basically what the pack is going to be when we go to put voltage on it. So we have to current limit, because yeah, these will put out like 200 amps, no problem. We have to figure out some current limiting resistors to put them through, and probably go for just a couple of amps, 1 or 2 amps, should be completely fine. Nice slow charge, and monitor what's going on. So yeah, take it apart, check the cells, rig these up in series, maybe put a current shunt in this guy so I can monitor what current's going through it. Yeah, connect it up and hope for the best. If you're looking at this video because you're interested in trying to revive a big pack like this, this is just for entertainment purposes. Do not do this. Where the amount of energy in this pack is just hard to comprehend. Something like if you shorted this guy out, if you put a dead short across wires while you're in here that were like the main series wires, you might be looking at 10 kilowatts, you know, that's going to get discharged out of this guy. If you drop something across a positive and negative, whatever metal thing you dropped on it is going to weld to it. And if one of these cells goes nuclear, the whole thing's going to go off and you're not going to be able to stop it, whatever you do. Even if you get a fire extinguisher, you're stuffed. I think it'll keep burning whether you spray a fire extinguisher on this or not. So don't do this at home. Do it at a friend's home. No, wait, that's not right. Yeah, you've been warned. If you're looking up a YouTube video trying to figure out how to do it, you're already screwed, man. Just don't touch it. Take it to someone who works on lithium batteries. Let them take all the risk. Now, I'd already started getting this guy apart and talked about all this stuff already for about half an hour and realized my microphone wasn't working. Yay! So this is almost apart now. I'm just taking out the last screw on this panel. Actually, then we got to take out the screws on the top panel. And what's actually concerning me a little bit, as soon as I crack this bottom panel open, I got a whiff of a chemical smell, which smells like electrolyte to me. And that's normally quite a bad thing. That normally means something is, like a cell or something is ruptured. So we're going to proceed very gingerly. Yeah, the thing's hard to move around. Did I mention it's 22 kilos? Okay, I'm fine. Maybe. We'll just undo all the bolts up here. It's a good time to not be wearing any metal jewelry. You guys can't see anything. I'm just struggling with this pack over here with this 20 kilos worth of stuff. Oh. Oh. Oh, yeah, buddy. There's the case. Hello. I've been at work all day. It's been a really long day, a very busy, hot day, and I'm buggered. And now I'm wrestling with this thing. So I wanted to see a whole bunch of cells, but they're like in separate, like bricks. I'm just gonna throw him sideways. Careful. All right, there she is in all its reflective glory. Wow, look at that. I'm wondering if these are electrical connections along here. Sort of like bus bar kind of thing. All right, you can sort of see what's going on there. Okay, battery management board is this guy here. We've got all the individual packs Although it's a bit of a weird arrangement because there should be 20. And what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so yeah, they must be stacked like that or something like that. Yep, 20 individual packs. I'm just wondering if inside, I'm not going to take, I can't take anything further apart to see the cells. I don't know if they're big lipo packs in there, or I imagine they're actually 18650s probably, or 21700s or something like that, and just a whole stack of them in each one of these. They'd just be filled with them in like parallel. Each one of those 20 would be just a whole stack of parallel cells, and they're all seriesed up to give us the 72 volt nominal. Just got to put a new battery in my multimeter. And thank you, smoke alarm. I'm kidding, don't do that. Don't steal your batteries from your smoke alarms. It's got mains powered anyway. Kind of ironic that I'm stealing a battery out of a smoke alarm whilst doing something that could really need a smoke alarm. Oh, how would you be accidentally connecting up to the ammeter on your multimeter than trying to check the main series voltage on this guy? Ooh. All right, stop dicking around. We're just going to measure straight into the main power connections. 56.8, that was at 57.4 earlier, and yesterday was at 58. That's dropping pretty quick. Like, considering the capacity of the cell, you've got to discharge a lot to get down that sort of voltage. Like, you know, standby current, if this board's got some standby current, you know, this thing's got so much capacity, it shouldn't give us stuff. Like, it shouldn't drop hardly at all for ages, you know. I might want to actually check the standby current on this board. Something weird going on there. So that's the main positive going into the series pack. When I say series pack, we've got 20 cells all lined up in a big loop. We've got a main positive and a main negative. That's the main positive there. The negative, main negative, is coming out of this guy here, and it goes to the board. Board's got a whole lot of switching MOSFETs under here, and then the negative comes back out here, goes to the outlet. So this is the charging for the pack, and also the connection to the bike itself. So all the power goes through this socket in or out, with the battery management in the middle, you know, deciding whether it's going to get switched on or not. This guy here is all the in-between voltage taps. So we've got a wire going to every one of these series packs. So this battery management board can see what's going on, what level they're all at. And these are probably, probably balancing, I'd say. This would be the balancing section. The main power switching section up here, which really should just be an on or off. The bike itself would be the one controlling the actual power going to the motor. So this doesn't need to do any voltage control. It's just like on or off pretty much. So yeah, we'll get this connector out and we will probe those wires and just see what we've got on each cell. Keep saying cell, on each pack of cells. This thing's such a bugger to move around. Oh, I'm like, yeah. I'm just scared to get anything metal near this thing. Whoa, fuck me, fuck me. Okay, there's no voltage. Hold on. I just want to see if there's any voltage on these metal pieces or they're just like structural. So we're going to have to get access to this guy. Probably do it through... Oh, don't use your bloody multimeter leads, you idiot. I need to get that coating off so I can get to the main cell negative. Just tempted to go towards myself. Shouldn't do that. Yeah, not nervous at all. No, I'm fine. Okay, so to bypass this battery management board, we want that connection there, main positive, that connection there, main negative. I'm going to go off this guy here. Don't think I'll even need to remove it from the board, but I might. And then I'll be able to connect into the socket itself to get the... You can't even see that over there. It's over this way. Onto this wire, the socket. Be able to plug into there to get the main positive. And it's definitely not shaking. I've only had 4 coffees today, so that's fine. If I'd known I'd be doing this, I might have had less. But here we are. Maybe we could actually do a little comment on build quality here. Kind of like I do with the e-cig stuff. It's all pretty good in here, like it. I mean, it's got to be good. Look at the thing. It's $2,500 a battery pack. We've got 2-layer board here. I'd say the board underneath is probably connections onto the cells themselves. They are very well insulated. Got multiple areas of insulation here. Fabric, that'd be another layer underneath. heat shrunk there. Lots of sealant, hard sealant on everything. So any component that's going to vibrate or rattle, like this little guy's even got sealant on him. Every screw has got sealant. This whole battery tap bundle is sealed in place so the plug-in socket can't come apart, as well as the pins on the backside of the socket. More fabric layer on the wire bundles. Nice big heatsink here. We've got thermal pads, squishy thermal pads on the MOSFETs, just like what you'd see on a graphics card. Not on the main GPU die because that's they're not thermally conductive enough for that kind of heat load. But for the memory modules and MOSFETs in the VRM, they're pretty much the same, that weird squishy stuff. Yep, so we got a heatsink there and connected to this big bundle of MOSFETs. Conformally coated, so... Oh, where's my UV light? You can see the UV reactive conformal coating, which is basically everywhere. Well, it is masked off actually, because it's not on the edge here. It's all just around the components. But yeah, coating over pretty much everything. Right to this side, even over that little patch of board there. Yep, nice thick conformal coating on everything, which is great. Everything's stuck down really well. More sealant stuff shmoo in between these resistors just to hold them in place, because you know, you're thinking it's in a bike, so you're going over bumps, everything's vibrating. Yeah, might have an accident. That's the other thing. Like this thing, you know, people crash their bikes all the time. This thing could be in a vehicle that has an accident at some point. Anything with mass that can move or shake loose on the board, they have paid attention to put sealant in, just so nothing can vibrate, nothing can move around. Because if you have a component that's got a bit of weight to it, say like this chunky resistor, and it's sitting up on its leads, even if it can vibrate slightly, over time it's going to fatigue crack those legs. So seeing lots of area around here which has got extra solder on it, probably current carrying capacity, just to kind of beef up the board. And they've even soldered on, it's a bit hard to see there, zoom. Oh, it's so dark here, it's gonna be hard to see anything. Well, there's a look across the board anyway. There's sort of a bar of metal that they've soldered to the board, and that would be for extra current carrying capabilities as well, and you can see all this extra solder. So yep, I've obviously designed, I mean, it's got to handle a heap of current, so yep. What have we got? I noticed there's a shunt down here that you can't quite see. Oh, I can just lift the camera up. Way, there we go, it's not screwed down. This guy here would be a current shunt. That's probably all the current's going through that. It's a big chunky copper current shunt. And we can also see the cables while we're down here. Nicely zip tied in place. More sealant on screws on this bottom board, which again I think is just an interface from the actual cell connections up to this main board. But yeah, it is a quality board. It's all really well laid out component wise. It's got that nice conformal coating. Everything's held down nicely, and more beefing up of the current carrying capability of the board with another bar of metal soldered on. And we're going to have to peel the sealant out of that connector and get him apart so we can read the different cell voltages. Let's turn our attention to this connector. Got to be careful with the plug because it's got to go back in, but all these wires are connected to cells, so if this got shorted to ground somehow, we'd be in very bad shape. It'd just absolutely fry that thin wire back to the cell. Here we go. Oh, you can't see what I'm doing. I'm just trying to push this plug back, obviously very carefully. Oi! Okay, we're good, we're good. Sweet. The voltage taps actually alternate in this guy. So you'll have like number 1 there, number 2 there, number 3 there, number 4 there. We'll just run through one row and have a look what we're seeing. I need to write this down. Oh, I can't use my phone because that's what's the camera. 3.29. .29, 9.84. we're buggered. All right. Double check, but just looking at what voltage each pack is at, and we're buggered here. 0.9 volts for one of the packs. All these other ones are looking good. 3.3, 3.23, which is fine. Yep. Oh, that's a bummer. All right. Well, that is a bummer because we've got one pack down at 0.9 of a volt and another one at about 2.53. So we've got two low packs. The rest are all between 3.2 and 3.3, which is good. But no, I can't charge it. Can't do the sneaky charge, I don't think. I mean, it's one pack's buggered, so that would mean all of the cells in that one pack, 1 out of 20, are basically stuffed because they're all down at 0.9 and don't know how long they've been sitting there for. So yeah, I don't want to try charging that one individually because there's something wrong with that one. Yeah, which means game over. Game over. Whole thing, 2.5 grand battery pack goes back to the supplier, and I guess they can have fun with it. But there's a look at what's inside a 3.24 kilowatt hour lithium battery pack. And let's see if we can zoom out a little bit. There she is in all her useless glory. Look at this big bugger. Yep. Gonna pack it back up and kick it down the street. Hope you enjoyed having a look into a huge battery pack, even though unfortunately we didn't get anywhere, didn't get to do our tricky charging. But yeah, I mean, if you've ever wanted to see what's inside a hulking big thing of batteries, yeah, there you go. What a solid unit. Just a pity we couldn't revive it, and yeah, we got a dead pack. Anyway, thank you very much for watching. Cheers.